Hey everybody, my name's Mick Douglas, and I am super excited to be talking with you guys about one of my favorite things to play with, and that's microcontrollers. And there's a lot that you can do with them, but what we're going to be talking about is how to turn a microcontroller into a HID. And we're going to start off with a demo because I like to tempt fate. So let's kick things off with a very easy and lightweight demo, which here's my microcontroller, and if all goes according to plan, I typed this all just from hitting this little button. And so what I'm going to do is show you how to set this up and how you go about doing this. So let's dive in. So first of all, SANS is getting a lot more into the hardware hacking scene. And several instructors, myself, Larry Pesci, and Micah Hoffman, have kind of formed a little cabal, if you will, and we've been playing around with how we want to do hardware hacking and instructing it at SANS conferences. The first one we had was a while back at Network Security Las Vegas, so last year, and we made TV Be Gone type clones, which were little devices that when you pressed a button after you soldered it all together, it would emit infrared signals and power off most TVs. And it worked out okay, but there's a couple problems. One, with the pandemic, it's hard to get all the kit and things out to everybody, so we needed to come up with a new platform, a new way of doing this. And so what we're going to be doing is showing you some recommended things that you can do while you're locked up, while you're waiting for airlines to open up travel. If you want to get into this scene, it's actually not that hard. So a little bit about myself in a moment, but first, this talk, we're going to be focusing on some of the more foundational things. If you are already an accomplished hardware hacker, this talk still is for you because chances are you might have forgotten some of the difficulties, some of the tribulations that people have in getting set up for this. It may feel easy to you, but if you've never done it before, it's just weird. And one of the things that I really need you to understand is that what we're going to be covering is not difficult at all. It is a bit different. So just kind of set things just back and realize that it's okay to have some struggles and some frustrations. What I'm going to do is try to remove those frustrations by showing you some really fun things that you can do with these. Now, microcontrollers, this one here we'll be using throughout the talk, is but one of many types. And the thing that's neat about microcontrollers is that you can reprogram them to do a wide variety of things. And most importantly, you can make them be a HIDS, a human input device that's based off of USB. And these are things like keyboards, mice, clickers, etc. Typically, the 99.9 repeating a lot of times, these HIDs are perfectly normal and just happy devices, except attackers can make malicious ones. And what we're going to do is show you how to make your own. And this is a skill that every pen tester, in my opinion, should have. And I'll actually share with you a very interesting story, or maybe give you a tease to a very interesting story that you can go out and learn a little bit more about, because frankly, these are just amazing devices. Now, before we dive into the device that I just showed you, I want to give you just a brief little history lesson. The tool or the framework that kind of got this started off was a device called the Teensy. And the Teensy is a USB programmable Arduino class system, meaning you can use things like Arduino IDE or the Arduino C libraries to control it. And starting with the Teensy 2.0, you had the ability to program that device into announcing to the USB bus that it was a HID, that it was a human input device. basically a keyboard. And you could use either JavaScript or C to code these systems up and make them do what you wanted to do. Bear this in mind because I'm going to be mentioning this tool or this particular product in just a few slides. Probably the most popular one that many people are familiar with is the Rubber Ducky. Now, the Rubber Ducky has quite a few advantages, and I'll be referencing this tool one more time in the presentation. But the thing that's interesting about the Rubber Ducky is that it's about the same form factor as the Teensy in terms of size, but Hak5 has made a few modifications for you. This is not a Teensy device. It's sort of kind of like a Teensy, but they've made a few modifications. Most importantly is they've put a USB alpha USB adapter so that you can plug it into any USB device or host, like a laptop or a computer, and it will start acting like a keyboard. Now, what you're looking at here is the Rubber Ducky Deluxe. What makes this a deluxe? There's no difference in the hardware. What's different is that you get this shield, this plastic wrapper that you can crack open and snap shut, and thus it looks like a real network drive, or not a network drive, but a USB drive that you would plug in, and what will happen is your Ducky script activates, and I'll show you those in a little bit. Your Ducky script activates, and then your computer goes ahead and does malicious things. The other item, though, that is gaining popularity, and the one that we will be using on future hardware hacking virtual talks, and probably even when we go back to having conferences in hotels and conference centers, is this device, the Adafruit Industries Circuit Playground Express. And that's the device that I was using when I had the text stream to Notepad. And you can get these Adafruit devices, and there's quite a few reasons that I would recommend that you check these out. I want you to understand, though, that there's far, far, far more devices than just these that are out there. There's specialized microcontrollers. This is one that I use for a drone. It's a programmable drone microcontroller, and oddly enough, it too supports the ability for me to use it as a human input device if I chose. But there's others. So here's again, the Adafruit one, which is nice and easy to work with. There's another one out there that is a very small form factor, and this is the Tiny Circuits system I live in Ohio, so I'm really proud of Akron, Ohio. Tiny Circuits are run by Akron, Ohio. And what's interesting about this device that you're seeing here is this actually can, there's a display that can do 300 by, I think, 180 pixels. So you can actually do old school Nintendo games or tiny TV type projects. So this is a very rich playground in a rich environment. And so a lot of people, when they first start playing around with these, they say, well, okay, Mick, I've heard the sales pitch and I'm interested. What can I do with these sorts of devices? And the answer is, well, it's a keyboard, so you can do anything that a keyboard can do. And if you really stop and think about it, keyboards can do anything. Like literally anything. You can stop a computer, reboot a computer, kill programs. And so having a physical device that you can attach to a system and have it do a preset series of actions, well, it's phenomenal. And one of my favorite resources, and part of the reason that the Rubber Ducky became so popular, is that Hak5 and the community around that hacking scene made a variety of scripts that are available to you. And I want to show you just how many payloads there are. These payloads allow you to do a variety of things, from opening a PowerShell script to doing all kinds of weird like netcat relays, whatever you want. And I'm going to be clear, these scripts are not the end-all be-all. You can modify them. And frankly, they're really, really easy to modify. Let me show you just one of them. What happens is in Ducky script, what you will do is issue a series of commands that tells the chip what to do. Now, one thing that I do want to point out are these delays. A common mistake that people will make when they're programming microcontrollers is they don't take into account that these programmed keyboards, which is basically what they are, these programmed keyboards will type super, super fast. So fast, in some cases, you can actually have your typing get ahead of the application that you're trying to launch. So you absolutely need to test these, and I'll give you some pointers and tips on how to go about testing these toward the end of the talk. Now, one item I do want to circle back a bit. I mentioned that the Teensy class devices are programmed in C or a Arduino script, which is basically JavaScript. This is a different language. This is the Ducky syntax, and some people find this to be a bit easier to work with than others. If you find this to be helpful for you, go ahead and get a Ducky. That's fine. What I am encouraging you to do, though, is to push just a little bit differently. There's nothing wrong with Duckies. In fact, hey, I owe beers and stuff to the folks who did Hak5 stuff. But what I would encourage you to do is move and push a little further. If you're not a Python coder, I would encourage you to play around with something called Circuit Python, and I'll be sharing with you how to do Circuit Python in just a little bit, and I'll show you just how easy it is. We'll be loading up a script that Larry Pesci, one of the other folks on the hardware hacking side of things, has been doing, and you'll see that it's actually really quite simple. So now at this point you're probably thinking, okay, I have scripts, I have the ability to load things, like I can put stuff on text. But let's think about this a second. Having this, that's not really scary. If I went to a client and said, like, look, I can say, hi, my name is Mick Douglas, that seems like that's not that neat of an attack. That's not something that would keep them up at night. How can I use these as part of a pen test? Well, what I would encourage you to do is take a look at a presentation I gave over 6 years ago. And don't let the age of this presentation fool you. This attack is still viable today. What I did is I conducted a USB splice attack. Now, when I actually deployed this microcontroller for this attack, I had it packaged up and bundled in a smaller form factor. Here I've kind of exploded it out to show you how just one way you could potentially splice in a USB device. And the item that's in that red square there is the Teensy that I showed as the first type of HID in this presentation. So these are very viable and scary tools to use as part of a pen test. In this scenario, if you watch this video, you'll see that I attacked a point of sale system by splicing into the access panel, and I arrived on site with a specialized wiring harness, basically, that would fit into the management panel of the pin entry device. So this attack works, and it works well. And a lot of people have this misunderstanding of these, thinking that because travel is somewhat restricted, we have less chances of pen testers putting these on our networks, and that's simply not true. I have seen and even worked cases where the attackers had spliced devices like this into high-end keyboards, and then they would ship the gaming keyboard to a developer or somebody and say, hey, you won our prize, you won the sweepstakes, and they plug in a weaponized keyboard, and yes, there is one keyboard, but actually there's two keyboards. They're working with the one physical keyboard that they see and can touch, but there's one that's already programmed that will detonate and start executing live, code or doing whatever the attacker wants. So this is a very serious thing. It's a fun area to research. It's a very interesting area. I hope that you're excited and enthused as I am. And so what I want to do is talk a little bit about the good old Circuit Express from Adafruit. Now, there's a couple things that I want to point out. Is that the debug is a touch trickier on these devices. In a moment, I'll explain some of the pros. Is that there's a lot of sensors and components on here, so sometimes you can get into a situation where it's a little tricky to debug this. The other is that it's not too stealthy. I mean, if you physically compare these two systems, I mean, this clearly is the winner because it's so much smaller. The other thing too, let's swap out for a different one that I've programmed differently. I want to show you something that's quite interesting about these. Is there are 10 RBG LEDs on these, and having a whole bunch of blinky lights on a system is not something that's going to be really helpful. So blinky lights, not good. Now you certainly can control these, but this wouldn't be the greatest stealth tool to use in the real world. But, and this bit's important, I think that it makes an absolute fantastic learning system. And the reason why, there's a lot going for it. One, the online community around the Adafruit Circuit series, the Circuit Playgrounds. There's the Circuit Playground and the Circuit Playground Express. I would encourage you to get the Express edition. It has a few more features. We'll get to those in a moment. But the community behind this is fabulous. There's almost no trolls in the community. Please don't take that as a challenge to inject maliciousness, but it's just a great learning environment. The other thing is that it is well documented. Now, I'll be honest, I try not to read documents. If I can avoid it, I will. But when I need to read the documents, it's very well documented, and frankly, it includes a lot of pictures, which is helpful. And then the other thing is it's got a lot of components. This is quite large, but there's a reason why. Look at all the features that this thing has. You have so many components that you can start working with. And I would encourage you to get comfortable using these, because having the ability to interact with these will make your HID-based attacks much better. In fact, one of my favorite ones to play with is a 3-axis motion accelerometer, because that lets you know that a device is being moved. And I have been on cases where people have spliced similar type things, usually these smaller form factor devices, into mice. And so they wait until the user is actually using the mouse to activate, then a countdown clock begins, and if you haven't used the mouse for a while, then the payload is delivered. And the reason that you would want to do that is, well, the machine likely is unlocked and you're able to interact with it, and you can then start doing things. I've also seen where people have spliced in on buttons on pin entry devices and then waited a few moments to trigger, because the reason why you don't want just to have this thing wake up and immediately do evil is, well, frankly, if the machine, whether it's a point of sale or a Windows server, is in a locked state, you need to wait until that thing is available. Now, some of you are probably saying, well, I like to do things the hard way. I like to do things manually. I would prefer to have a very small component like the tiny circuits and just buy each individual component. And that's fine. In fact, you can learn a great deal for that. There's two downsides to that, though, is What I love is having all those components saves a lot of time and money. And frankly, right now, shipping is a lot trickier than it used to be because the airlines are not moving as much. Most of the commercial shipping that happens globally is done through unused cargo space in commercial airliners. And I've had a couple friends where they were like, hey, I got these devices, these chips that I ordered, 5 weeks ago, and I forgot what they were for. Um, I know it sounds like I'm shilling for Adafruit. I'm not. I am a big fan, but I don't get any money for recommending them. These devices are shipping quite easily and in reasonable time frame. Okay. So by now, I hope you're a believer in these devices if you don't have such a thing. So how do you go about programming the device? And I want to be clear, just as in the Unix environment, people get into religious wars over which text editor to use. I've seen people get into very big religious debates over how do you program these devices. What I'm going to do is show you the method that I use. And I would recommend that you use either the Arduino IDE or a Python editor like Mu. I'll be showing you the Mu editor. And the reason why I recommend that you do these is, yes, they are a little more complex than some of the block-based coding ones. The downside for those easier to use ones is that you don't have as much flexibility. And so I'm willing to pay a very small inconvenience price. Sometimes the setup's a little trickier, but usually it's almost always worth that price. So the first thing that you're going to need to do is set up the Mu editor. Now, downloading Mu, you're going to do that based off of which machine, what OS you're using. I want to show you just how easy it is to get going on Mu, though. Let's get Mu in. There we go. Okay, once you install Mu, the most important thing that you will do with Mu is right here in this upper left corner where it says mode. If you neglect to set the mode, you're going to have a world of hurt. And the reason why is when you set the mode, you are telling Mu what communication libraries need to be used. Because we're using the Adafruit Pixel Express, you're going to do Adafruit Circuit Python. So once you've selected that, then you can plug in your device and start coding it. Now, the second step, once you have Mu set up, is that you need to configure your circuit bootloader. And I'm going to be honest, this is the trickiest bit. It's not difficult, it can be a little frustrating. What you do is you plug in your device. You plug in your device, and then what you do is you're going to double tap the reset button that's dead in the middle, this reset button. And the trickiest bit is getting the timing correct. I don't have any advice other than just play around with the timing. If you get it wrong, all the LEDs will turn red. If you get it right, they will turn green, and this bit's important, they will stay green. So double click, and didn't work. Okay, I'm having demo fails. Third time's the charm. Come on. Okay, let's try a different one, just on the hopes that that works for me. Okay. Whether it was nerves or whatever, I now have all green, and I realize that's not showing up terribly well. Let me see if shielding that. There we go. It's all green. So once it's all green, what you have to do is update this system. Now, the way you do the update is inside this device, you have a drive, this CPlay boot. And what you need to do is download the latest library driver from the Adafruit website, and you simply drag and drop that into the boot device, and it will take care of the firmware flashing for you. I've already done that, so I don't need to do that to this device. Once you have done the flash, simply hit the reset button one time, and it will boot, and you will see that instead of saying the boot device, the drive changes to Circuit PY, which means this is the Circuit Python library. And now what you can do here is you can modify the code that's actually on this device. And in this case, my code that I'm working with is, I've named it code.py, and that brings us to step 3, which is the get coding. And the get coding bit, well, frankly, that's the easiest. So let me show you how you would go about doing this. Once you have it set up, you would simply load your project file that you want it to load. And in this case, I've already made some edits to my code PY. And here we now see the Python code that was made. And a lot of people who have never done Python coding kind of get nervous at this point. And I want to assure you that this is probably the most gentle introduction to coding that you're ever going to have, because all you have to notice, all you have to care about are what your buttons are. And there's the A button and B button, and they're very tiny, but they're labeled actually on the circuit board as to which button is which. And then you can assign a series of actions, whether it's a bunch of keys that are pressed, and this is the stuff that I did for the demo. And now a lot of you are saying, can it really be this easy? This seems way too easy. Okay, what I do then is I save. My code is transferred to that system down to my Adafruit circuit. And now, if all went well, key or button key A is now reassigned to yes, it really is this easy. So let's see if my demo worked as scheduled. All right, moment of truth. We hit button A. Ooh, it's saying button. Okay, there we go. Sorry, I was hitting the wrong button. Yes, it really is this easy. As long as you follow your, as long as you press the right button. So if pressing the right button is the trickiest bit, you got a 50-50 shot. My goodness me, it seems like it's pretty easy. So just have at it. Play with these sorts of tools because I think they're fantastic. So let's see. I've got a couple questions in Zoom. So yes. Okay. So there is a comment about specific chipsets and how they work. So not every class of Arduino supports this. One of the things that I would encourage you to do is if you're going to use something that is not the Circuit Express or the Circuit Playground Express, if you're deviating from that, make sure that it does support HID mode. And it's important that you specify HID mode. And the reason why is many people will say output or text output. What they're talking about is serial output. That's not what we're doing here. We're exposing this as a USB device, not serial. So that's a great question, and I'm glad you brought that up, and just be mindful of that. Oddly enough, the most expensive devices are not always what you want. Some Arduinos are very, very full featured and they do great jobs, but for this, you certainly don't need to spend a ton of money. Anything north of $50, I would start questioning. You might be spending money that you don't need. So that was a great question. Could you use the lights to indicate active traffic? And the answer is yeah. I mean, you can use these LEDs however you want. Now, the it might be a little tricky. One of the things that you would need to do is have an input so that the microcontroller, whatever it is, knows which directionality traffic is going. The way I would do that, if I wanted to do that with this, is I would set this up as a serial port. So my USB would be a serial port, and then somehow on the machine I would stream that there's a certain amount of packets in, and you could do something like having a level meter, like a gauge, where this dials up based off of how full the pipe is, for instance. You absolutely could do that. Okay, next question. A three-axis motion sensor to detect movement. Oh no, one more reason to use a trackball for life. Well, I'm a trackball fan too. The downside is I could splice in and just listen in on XY updates on the USB bus. So hacker's going to hack. You're not always going to be able to dodge them. Ah, excellent question here. This is a fascinating one. Can you talk about why somebody would choose Python circuits versus C? Wow. Well, um, one of the things that you have to be cognizant of is that regardless of which class of device, whether it's one of these smaller ones or these larger ones, you have a very limited amount of memory to work with. And so Python, while it is nice and a great environment, it's not as tight as C. Also, so space savings is usually why I would do that. Also, as you progress with microcontrollers, you will find that even the Python eventually becomes limiting. And there's a whole community of people that take advantage of some of the quirks with how the hardware works and are able to push these devices to do things that are really bizarre and things that you wouldn't normally expect them to do. One that springs to mind is um, uh, lesser. It's not done so much anymore because the microcontrollers have gotten better, but in the drone community, for a while, there were people who would write the drone code in C and use temperature, a thermoresistor, basically a temperature sensor. And by using C, what they were doing is they had more control over the components. They were getting the readout, yes, of the temperature on the board, but they also were taking advantage of a weird quirk in the timing chip on the microcontroller. And I know that I don't have a good enough view, but this chip here, the smaller of the two, one of the functions that it does is regulate timing. And as the chips heat up or cool down, the timing values start drifting. And they use that as a way with the temperature control and the timing. If you had a drone that was going too high, where the temperatures are getting cold, because at like 30,000 feet, it's minus 40 degrees, what would happen is the timing starts getting off. And depending on what you're doing, if the timing gets off, the flight control may not work anymore. And so what they would do is adjust the timing based off of that. And I don't know how you would do that in Python. So that's a fantastic question. I know that's a bit of outside the the bounds of what we were going to be covering. But so that's just one of many reasons that you may opt for C over Python. I would encourage you to use the Circuit Python just because it's a little easier. But if you're very handy with C, by all means, knock yourself out. Like I'm more of a does it work? So I hope you see that this isn't that difficult, really. Like you're just writing slinging code, and later on I will publish the template file that we used for this demo. It's shockingly easy to work with. Now, at this point, a lot of people are like, "Well, but Mick, this is basic, right?" Yes, it is, but I have full keyboard access. And if you stop and think about it, literally everything that you do on a machine can be done via keyboard access. So start thinking about these sorts of things and be mindful that attackers will do them. Now, at this point, you're probably really excited and like, yeah, I can't wait to do keyboard input devices. Like, yeah, let's go hack all the things. Not so fast. Not so fast. There's a couple problems that you need to be aware of. When I was prepping for this class, remember that first demo that I started with? Super basic demo. What I was doing when I was practicing this, I just started smashing this button just to see, like, does it work repeatedly all the time? And the reason that I did this is I know that there's a certain number of times that it won't work. And some of you have already spotted the problem here. Let me show you the fun you can have with a programmable HID. It's programmable. One of the times the P character was not, the PR characters were not set. So it's not that the code was wrong, it's just something somewhere on the bus glitched. So if you're ever in a situation where you're going to be doing these as part of a pen test or some sort of engagement, it's really incumbent upon you to test the fool out of these things. Run them multiple times, detach, reattach. That's where a lot of times you'll have problems. If you have triggered conditions, especially like I mentioned, where you're using an accelerometer, those you need to be very careful of, because sometimes if you go outside of the expected range, so say you're using mouse movements as your trigger, if somebody moves the mouse too hard or too fast, they can cause the sensor to get in a confused state and it needs to be reset. So please do yourself a favor and double check. If you are in a spot where you're needing to verify that your commands worked, maybe as part of a pen test, I would recommend that you at some spot have a machine ping your own IP, which is nice to let you know that you got to a certain spot. Maybe have a netcat connection that executes a command letting you know that it got to a certain spot in the commands is nice. Chris Dale, who's a SANS instructor and a buddy of mine, hi Chris, what we once did, we were teaching in the Middle East. And what was interesting was at this location, they had rented the laptops for the students, which was neat. You know, we would have all the like uniform laptops and everything would be great. The only problem is the company that we rented the laptops from absolutely did not configure them at all according to what the standards that SANS told them. They didn't have the firewalls configured correctly. They didn't have the right user accounts. They didn't have all this stuff. Well, this is where microcontrollers and things like rubber duckies can be used for good. What we did is, and we spent a fair amount of time doing this, we built up a script that when you plugged it in, it would create a batch file that made the config changes that were needed for the class. And then the neat thing that we did is we had the machine power down. And So there were 95 laptops. This was a very large classroom. And what we did is we plugged it in, moved to the next machine, plugged it in, moved to the next machine, plugged it in, moved to the next machine. And the set of configurations and software that needed to be installed was pretty substantial. So it would take a few minutes for each machine to do everything that was needed to be done. So we went around machine to machine, just plugging in this device, taking only seconds per machine. And then when it was all said and done, we went to lunch and we came back, and any machine that was still running meant that something went wrong in the script. So you always need to get a little creative with these scripts and these sorts of uses of these tools, because they are not perfect. Murphy will come and bite you if you don't take care to watch for that. So one other thing that you need to be aware of is virtualization. I have had a very mixed level of success using these devices in a virtualized environment. And what I mean by that is when you plug that device in, ideally, what you're hoping to see is that VMware or VirtualBox or Fusion, whatever platform you're using, it will pop up and say, hey, a new USB device has been attached. Do you want to attach it to the host or to the virtual guest? It doesn't always trigger. It becomes very frustrating. So what I would recommend that you do is give it a try. If you want to install your tooling and your configuration components on a virtualized host, or I'm sorry, a virtualized guest, feel free to do so. However, be prepared to install on a physical system. That's usually the path of least resistance. And you'll note that I am not talking about one operating system over the other. My advice to you is use whichever OS you're most comfortable with. You're a Mac user? Go ahead, use Mac OS. If you're a Windows user, use Windows. Linux, likewise. I will say that if you're concerned and you're like, I don't want to commingle these tools, how do I commingle these tools with my OS? I'm worried about that. You could do these on Raspberry Pis as a low cost way of setting that up. That's very, very common in this community, is to have a Raspberry Pi running like Raspbian being the component that runs things or programs sets up the microcontroller. So Ken asks a very good question. Do you need to worry about unmounting or properly ejecting the Adafruit USB devices? And the answer is it totally depends. Here's why. If you are using the drive and you're saving the code to it, you absolutely have to wait for the code to finish writing. Ideally, you do the nice, eject. In the purposes of the demos, I was just yanking them out, which not the kindest thing. Once you have them flashed, though, to act as a keyboard, these are keyboards. So you can plug and unplug them easily, and there's no worries at all. Now, those of you who know me know that I do pen testing, but I also love defense. And what I want to do is spend just a few moments talking about how you defend against these attacks. And let me tell you, these are some of the easiest attacks to defend against. Let me show you just how easy this is. Right now, I don't have any USB, I don't have any device installed. So let me oh, wait, I do have it plugged in. Okay, so this is plugged in. I'm sorry, I thought I had unplugged it. Watch what happens to my HID components when I unplug it, okay? The count will go down, spoiler alert. It will refresh when I unplug it, okay? So now it's refreshed and we have fewer HID devices as expected. But I want you to see just how noticeable this is. This is fantastic, okay? Those of you who know me well know that I love PowerShell. And what I'm doing here is this is a command that says get sim instance class name Win32PNP device, plug and play devices. And HID, USB HIDs fall into this class. Now, I'm not going to get into the details, not getting into the details. I just want to show you how easy this is to do, okay? This measure object line is the equivalent of the Unix command wc-l, word count-l. So when I hit enter here, it's going to tell me how many devices I have. So, okay, 56, whatever, all right. We don't really care that much about this number, but I want you to see, just plugging in one device, and I swear to you, this is the only change I'm making to this machine. You would think that it would only go up by, what, like 1, maybe 2? It absolutely doesn't, at least not for this particular one. Watch what happens. Same command, one device, huge increase, noticeable increase. So all I'm telling you is build your baselines. If you're worried about this, these are easy things to detect. One of the easiest detects, in my opinion, and a very, very low false positive one, is look for devices that have multiple keyboards. Now, okay, fair. If somebody's using a laptop dock and an external keyboard, they will have 2. Okay, 2 is the normal number of keyboards. If you see 3 keyboards, like, investigate. It's literally that easy. So I strongly, strongly recommend that you start looking for these sorts of things. All right, how do you control, okay, so go into some questions here. How do you control what circuit Python runs if you have multiple Python programs installed? Okay. So the way that you control this is the same method that you would use for if you have multiple Python instances on your machine. So based off of this, I'm assuming that you're talking about a Raspberry Pi. Just look into how Raspberry Pis support multiple Python instances, and you can solve for that. The other thing that you can do is take advantage of the Python virtual environments. That gets a bit beyond the scope of this talk, but I'd absolutely be willing to chat in the Slack after this talk is done. So do these devices mimic MAC addresses? And the answer is yes, they can. Am I running out of time? Did I go over?
Just slight over.
Oh, okay. Well, then you know what I'm going to do? I'm just going to wrap it up and just say, look, these things are fun. They're easy to play with. Start looking for them.
I'll give you a better one.
Yeah.
Do you have a hallway channel on the Slack channel?
I do. Micah and Larry, thank for all your help in getting this going.